We have been studying the chapter 1, namely motion along a straight line. Now, we have been studying various topics. Now we have come to the final topic in this particular chapter, which is dealing with problems concerning varying acceleration problem. That means they are not constant acceleration problems. Now the acceleration is varying with time, and hence we have to deal with these problems by means of using calculus methods. What are the calculus methods? One is now taking derivative, that is differentiating, or by doing integration. So then we will now study this, how to solve such kind of a problem, what is a method to follow. Now, first of all, there are four variables involved in this. What are the variables? One is displacement. We call it as either S or X. Okay, or X. And then velocity V. And then acceleration A. And of course now time T. Now time will be the mostly the independent variable. That means that every other variable like the displacement or velocity or A will be a function of time. Usual problem will be given like this. They are actually direct and then straightforward. That's what now we have given here. That means now the the other three variables, namely displacement, velocity and acceleration, are usually defined as functions of time, and therefore now given data in the problem will be a function of time, based on which some question will be asked concerning the other variables. Now, now so then we just now start with this. This is what that is functions of time is one type of problem. Then what is other type of problem will be the functions of displacement. Okay, we will now start with functions of time, which I said is a straightforward methods. Now, what is the straightforward method? Okay, let us say now the displacement is given as function of time. As I said, no, displacement symbol may be used as either S or sometimes X is being used. So both are same of course, displacement. Then f of t means the function of time it is given. Then what do we do to calculate the velocity is we take derivative. Ds by dt represents velocity. If velocity also will now turn out to, because once you differentiate this, you get again velocity as a function of time. Now I had used this particular symbol f of t here as well as f of t here. In fact, mathematically we should not use the same f. We must actually call it now g of t. And of course then when we go to now differentiating to get the acceleration, I should have used as h of t. That means different functions. Whereas now this gives the impression that it is the same function as this, which is not so. But I don't want to take too many kind of variable names. Therefore, I just use the same thing as f of t. F of t this is now a different function. That much only we should understand. Okay. Now coming back to the subject here. Therefore, now displacement is given as a function of time. Now this may be usually the given data. Then what we do to get the velocity is we just differentiated ds by dt with respect to time. Therefore, then you get velocity also as another function of time. Then you want to know the acceleration. Then you differentiate it once more velocity with respect to time. You get acceleration with respect to acceleration as a function of time again, as a different function of time again. Now, depending upon then what is the data given. Okay, for example, now let us take just one example I'll give you for this. Let us say now a particle is performing a motion along a straight line as per this particular law, which is now displacement is given as 4t squared plus 3t plus 1. Now, then the question asked is, what is the velocity? What is the velocity at t equal to 4. And then what is the acceleration at t equal to 5? Okay, now these two questions I'm just asking. Then, now looking at this, I just want you to understand one thing. Now, as long as no displacement is a function of time power square. Now, this actually conforms to not varying acceleration. It is only constant acceleration. You understand that why? Because s is equal to ut plus half at squared is a s is a function of quadratic function of time. Okay, now here also now you can make out it is quadratic function of time because 4t squared. Therefore, this is not a varying acceleration, it's a constant acceleration because this formula is pertaining to constant acceleration. Therefore, sometimes you will be given this kind of functions and then don't get carried away saying that you have to do only calculus methods, because obviously looking at it, once that is, first of all you just see whether no displacement is a quadratic function or maybe cubical or power 4, then it is varying acceleration. Suppose it is only a quadratic function, that is displacement as a function of time and then is a quadratic function, straight away gives you the clue that acceleration is constant. Therefore, you don't have to go about your calculus method. You can go about simply because you know the equations of motion for constant acceleration. Therefore, now looking at this, you can say that half a t squared equal to 4t squared means acceleration is constant equal to 8. And then what is this particular term here? This particular term actually stands for ut. That means now initial velocity is 3. Therefore, then you can answer this question straight away without having to do any calculus. Calculus also, if you do it, you will still get the same answer, but then there is no need to do such kind of a exercise. Therefore, now you know this, because for a constant acceleration, you can calculate what is the velocity at t equal to 4, equal to u plus at. What is at? 32. What is u? Therefore, answer is 35. Okay, then what is the acceleration at t equal to 5? Acceleration at all time will be the constant equal to 8 is the answer. Therefore, now don't get carried, don't get cheated by means of giving this, because just look at the equation for s. If it is quadratic, straight away you know it is a constant acceleration type of problem. Okay, fine. Now we'll just go back to some other. Supposing it is given as 4t cube plus 2t. Now this is now t cube. The anything more than quadratic in time has to be varying acceleration, because once you differentiate, it becomes velocity equal to. Therefore, then what you do is just follow this method what I now told you. What I tell you now. Now you put it like this. If it is a function of time which is given, then differentiate it with reference to time, you get velocity. Differentiate once more with reference to time, you get acceleration. Therefore, just say no, straight away follow this. 4t squared plus 2t. And the velocity is therefore 12t squared plus 2. And then acceleration is given by 24t. Therefore, acceleration is also a function of time. Therefore, it is varying is fine. Now let's now try and answer the same question that is being asked. What is the velocity at t equal to 4? Therefore, put here t equal to 4, you get 4 means 16, 192, 194 is the answer. Then, what is the acceleration at t equal to 5? Now, it may be this equal to 120 is the answer, because t equal to 5. Or you can answer any kind of a question what is asked. For example, what is the velocity? What is the displacement when velocity is equal to acceleration in terms of magnitudes? That means what you are saying is velocity and acceleration have the same value SI unit. In which case at that time what is S? Now such kind of a question may look to be complicated, but then pretty simple. What they are saying is velocity and acceleration have the same value. That means equate these two. 12t squared minus 24t plus 2 equal to 0. Now we can solve for t equal to, you may have two values. And then if one of them happens to be negative, ignore it because time cannot be negative from common sense. Therefore, take the particular applicable value of t by solving this. What we are now doing is we are now applying this condition of the problem, which says velocity equal to acceleration into a magnitude. Therefore, applying this, you solve for t, and then to put it into the s function. Okay, put that particular value of t in this x function to get the final answer of what they are asking. What they are asking, what is the displacement when velocity and acceleration have the same magnitude. Therefore, understand such kind of a problem is what I call as now functions of time type of problem, which are actually straightforward to solve. Okay, now or under the same kind of topic of namely functions of time types of problem, you may have the ulta way of asking question. That is, you may have to apply integration. Like let us take for example, because acceleration is a function of time, and therefore now integrating acceleration like this, integral a dt will give you the change in velocity. Therefore now you get velocity as a function of time, and then integrating this velocity as a, I'm sorry, this is not a dt, this should be actually v dt. This should be v dt. Therefore, integrating velocity dt, then you get the displacement. Therefore, it becomes a kind of ulta way of doing it, and therefore now supposing, for example, now you are given a kind of a problem like this, then your particle is performing your straight line motion such that acceleration is given by 4t. That means it's a now time varying acceleration. Therefore, then what you do is, therefore, then the question may be asked is, what is the displacement x? Okay, as I said, now displacement symbol can be s or x. Okay, therefore, now both are same. Therefore, now they are asking what is x when velocity equal to 6 units. Therefore, then what you have to do is, okay, this again is a kind of a straightforward, direct way of asking questions. Now, therefore, then what we do is, first of all, now a is a function of time. Therefore, we will have to get v by means of integral a dt. What is that equal to? A dt 4t squared by 2 equal to 2t squared. Whereas, now you should be given another data is necessary, because they should give you some value, given condition, because now this is not v exactly, because this actually stands for change in velocity, because what is a dt, what is a dv by dt, dv by dt into dt gives you dv, therefore dv ka integral is delta v, the change in velocity. Therefore all these things and all you know already. Okay, now I'm just only now trying to revise what you know. Therefore then this gives you only delta v. Therefore, unless you know the initial velocity, you may not be able to find the velocity as a function of time. Therefore, now you should be given some particular data. It can be initial velocity, or it can be at t equal to 2, velocity equal to 4. In which case, what you have to do is, now this is like this. T equal to, therefore velocity equal to 4, t equal to 2, and then any t. Okay, velocity will be equal to, this will be equal to velocity at v equal to, at t equal to 2 it is 4, and velocity at any time. That means v minus 4 equal to 2t squared minus, now you put 2 here, it is 8. Therefore, velocity is given by 2t squared minus 4 is a function of time. Velocity as a function of time is 2t squared minus 4. Understood how it is done? Not necessarily only t equal to 0 they must give. They can give you any one particular value so that you can put the condition and then arrive at the expression of velocity as a function of time. Did you follow this? Okay, fine. I just taken only a little bit more complicated. Usually they will give you what the initial velocity means at t equal to 0, what is the value of u. Therefore, then that becomes straightforward integration of, you have to do that is u equal to 0 to v of dv will be equal to, now the function of time whatever you have got, you put initial time t equal to 0 to any t. Therefore, then you can get it. Now, this is the usual way of giving the data. I just want to complicate, I just want to now tell you about, they can also complicate it when they are giving the value of velocity at any other time also is perfectly fine. Then also you can still find the expression of function of time, that is velocity as a function of time. That's what I want to actually show you. That's why I just given you this data. Because there is one thing which I firmly believe is that whether you are appearing for the NEET examination or JEE examination, you should still be fairly good in mathematical skills, without which you will find it very difficult to do physics problems. Therefore, I just want to know for you to now appreciate the use of mathematical skills for any kind of a data which is given. We should not get worried about it. We should not be feared about it. You should not be afraid about of handling mathematics. That's the reason why I just gave you some sort of a strange data. Okay. Now come back to the what is the main subject. Therefore, now this is the velocity ka expression, that is function of time. Now what they are asking finally is, they are asking what is the displacement when velocity equal to 6. Therefore, now you put velocity equal to 6 in this case. Therefore, which means 2t squared equal to 10. That means t equal to root 5. Therefore, then what they are asking, what is x when it is root 5. Therefore, then you will have to still go into integration once more. Because what you got is, you got now v as a function of time. Now we should now get x as a function of time. Now s or x, as I told you, is the same thing. If we, in this case, now they are asking what is x mean, don't get worried about it. It's still only displacement, yes. Therefore, in order to get this from this v, you have to do integration once more to get the expression. So then what do you get the expression when you do the integration of? Therefore, s is equal to integral v dt will be equal to 2t cube by 3 minus 4t. Therefore, now you put t equal to root 5, you get the final answer. X is equal to how much? At t equal to root 5. That is at when v equal to 6. That means you are now answering this particular question. Okay, understood? No. Now this also is now purely straightforward, because we know that since the data given is a function of time, therefore now by means of straightforward either differentiation or integration, you get the other variables, apply the condition given to be able to answer what the question asked. Now this is not complicated, therefore this becomes now straightforward. Now we have a little bit more non-straightforward kind of problem. What is it? Now whatever given data will be a function of displacement, not time. Therefore, then becomes slightly little bit more difficult, a little bit more complicated. Let me just explain this. Now supposing now they give this, let us say now the starting is now time. Sorry, once again. Okay. Now starting is, they are giving time as a function of displacement. Therefore, then what we should do? If you now do dt by dx, that is, you take a derivative of this. Because as I told you that this is usually the independent. This is called as an independent variable is this. Whatever is given as a function of s means independent variable is s. Okay. Now the normal way of giving independent variable is only the time for all. Okay, whereas now they can complicate the matter by means of giving the independent variable as displacement, which means now the given this thing data could be that time is a function of displacement like this. Then what you have to do is you have to now differentiate it just like what we are doing there also. dt by ds if you take. Whereas now dt by ds actually is now reciprocal of velocity. Okay, therefore you just keep it in mind. Therefore now from here you get velocity by means of cross multiplying you get velocity, because 1 by v when you get as a function of displacement, you can also get the v by means of taking reciprocal. Therefore, then assuming that you are able to take reciprocal easily, therefore v is a function of time is what you have got now from the initial data. Next, then to get acceleration, you have to take this, because you know already that the acceleration can be also be defined as v dv by ds. Okay, if you want to see how it is done like this is, why it is like this is because you know that acceleration equal to dv by dt. This can be written as dv by ds into ds by dt, because we can cancel the ds. Now what is this? This is equal to dv by ds into, what is ds by dt is velocity. Therefore acceleration can also be written as v dv by ds. Therefore now that's what I have now given here. Acceleration is v dv by ds. Because now you have got v as a function of s, then you can actually differentiate it to get dv by ds, and then multiply by means of this v again to get the final value of acceleration as a function of s. Understood this? Now this is in case they give you not as a function of time but as a function of displacement. Now ulta process or the reverse process of this, that means integrating process, will give you back the original function what we want. Like for example, suppose now they are giving you a acceleration as a function of displacement. Then what you do is, when you now integrated a ds, what you get is delta v squared by 2. Okay, you want to understand how we have got is, because integral of a ds is equal to, as we know that a is defined as v dv by ds, therefore multiplied by ds cancel, therefore you are getting v dv, which is nothing but change in v squared by 2 value. Understand? Okay, therefore now that is how we have got this particular value. Therefore integrating this, I just repeat what I said. Now suppose they are giving acceleration as a function of displacement, then integrating it like this will give you the change in v squared by 2. Therefore, once you know the initial condition, because for all integration they must give you some conditions for us to get the full function, otherwise you will not be able to define the function. Now, okay, once you apply the initial condition of what they are given, then you can actually take out the velocity as a function of displacement. Because from here you can get velocity squared as a function of displacement. Then of course then take a square root to get velocity as a function of displacement. Then what you do is, now you just differentiate once more the 1 by v, because once you got this function, you can also get the 1 by v function, multiply by ds and integrate it, which you will get you only t. Why? Because now you know the 1 by v is nothing but dt by ds. dt by ds into ds will give you only dt. Therefore dt integral will give you time. Therefore you will get back this particular time. That means there is now a reverse process of what we have done here is now getting a reverse process. Now there can be such kind of a question which is giving in this particular manner. Let us take for example. Now it is given that the particle is performing a straight line motion such that now the time is a function of displacement x like this, x squared plus 1. Okay, now in fact you can actually convert it back into, let us say, x equal to t minus 1 square root of. Okay, supposing now I just give it as x square plus x plus 1, then becomes difficult, then become not possible to actually convert it straight away into x as a function of time. That means now here we are now doing independent variable is x and not t. Okay, suppose now they are given this, then they are asking, let us say, what is acceleration when t equal to 4. Okay, when t equal to 4, what is the acceleration? Then how do we do it? We just do this. Now t equal to x square plus x plus 1. Therefore now first step is now dt by dx. Okay, did you see this? First step is dt by dx, which is equal to 1 by v. Therefore we now take 1 by v, which means from 1 by v equal to dt by ds equal to what, 2x plus 1, which means v equal to 1 by 2x plus 1. Okay, therefore now we get, then what is dv by ds? Why we want it? Because next stage is now, because a is given as v dv by ds, in this case now dx rather. Therefore then we already know v as 1 by 2x plus 1, and therefore now we have to now take dv by dx is equal to, from here dv by dx is now again differentiating with respect to s, it is minus 1 by 2x plus 1 whole squared into 2. Therefore now multiply this by minus 2 by 2x plus 1 whole squared. You get finally now acceleration equal to minus 2 divided by 2x plus 1 whole cube. Understand, this is acceleration what you have got. This is the final this. Now they are asking what they are asking. They are asking what is the acceleration when t equal to 4. Now you have to put now t equal to 4 in the original given function 4, and then solve for x, and then apply this particular x value here in the final this thing what you have got, and then give the answer. Understand? Now it becomes very complicated. Therefore now I am quite certain that the NEET people need not bother about this kind of a complicated exercise. This will not come. Whereas now JEE people should be skillful enough to handle such kind of a complicated kind of problems also. That's the reason why I explained this. Whereas NEET students can actually ignore this kind of complication. But they will get certain amount of straightforward problem, even if it is the independent variable is x or s, that is displacement, instead of time. Okay, they can also expect. Now we'll be doing certain past asked question. Therefore you can come across. I will tell you also which problem is now suitable for NEET level, and then which problem is above the NEET level. Therefore you can follow my advice and then concentrate accordingly. Okay, now this being the case, let's now take up some of the problems and then try and see how to solve such kind of problem by means of applying the knowledge what you have now so far learned from my lecture. Okay, let's take this particular problem. If the velocity of a particle is given v as a function of time. Okay, therefore now becomes no straightforward type of problem where a and b are constant. Then the distance traveled, that means v as a function of time, they want x as a function of time, and then apply this limits between 1 to 2. Okay, 1 second to 2 seconds. Therefore it becomes now our type of straightforward type of problem, which is problems of the type A, which is functions of time straightforward. Okay, therefore now we can apply it like this. What is the method now? Because they are given v and then they want displacement s, integrate to get this displacement and apply the condition for limits, apply the limits of the time from 1 to 2, straightforward integration method. Okay, all of you know how to do this. Now let's take the next question. A particle of unit mass undergoes one-dimensional motion such that velocity varies as a function of displacement. Now comes our second type of problem where independent variable is given as x, and also now it is now starting with the given this thing is the velocity as a function of time, right? Now this is now starting with this particular data. Velocity as a function of x is given. Now what they are asking is what is distance, no, I'm sorry, not this, no, yeah, this one. Therefore then what they are asking is such that varies as per this is what is given. Then what is the acceleration of the particle as a function of x? Okay, that means it is also is from this. Now what we need to do it is, okay, let me just now tell you here itself. That means we know that acceleration is given by v dv by dx. Okay, whereas now v is given as a function of x, and the dv by dx we have now differentiated to get the dv by dx, and therefore this is the method. Understood? Okay, this also is now is not complicated, therefore it is within the NEET syllabus. In fact, this is a past question asked in 2015 of NEET. Therefore, you must know how to solve such kind of problems. Next problem, okay, also is a NEET level problem. Let us see. Now, displacement x of a particle moving one dimension is related to time. Therefore, now it's now a straightforward type A kind of question, where function of whereas okay, fine. Now this can be like this. What they are asking, what is displacement of the particle when the velocity is 0? Okay, now this either it can be like this. See, for example, now if you want to now convert this particular thing, because now the equation looks very simple, function looks very simple, you can also convert it into type A kind of problem by means of writing, because now the t equal to root x plus 3 is given. Therefore, from here you can write x is equal to t minus 3 whole square. Therefore, once you have written this, then it conforms to the independent variable t. Therefore, now it becomes straightforward. What they are asking is the displacement when the velocity is 0. Therefore, then what happens? We'll have to do the velocity equal to 0 means dx by dt, you just do it, 2 into t minus 3. 2 into t minus 3 is dx by dt, that is velocity. When velocity is now 0 means t equal to 3. Therefore, t equal to 3 means then you get x is equal to 0 from here. The answer is 0. Okay, that is one method. But if you still want to practice the type B kind of problem using this problem, you can do like this. You can do like what I have done here. Now keep the t as a function of displacement. Then what happens? dt by dx will 1 by v. 1 by v is 1 by root of 2x. Now, which may actually v equal to 2 root x. And then what is the condition given is velocity equal to 0. At velocity equal to 0, x equal to 0, straightforward. Okay, no. Therefore, now another way is what I have now given. What is this method I have now given here also. You can do both ways, doesn't matter, because this looks very simple. It doesn't matter which way you actually do it. Whichever you feel convenient and then confident, you can do it. I would actually personally advise you to do this method here, because this is a straightforward method, as I said, because it can be converted into a method which actually deals with independent variable as time, which is what is a straightforward direct method, and therefore that actually preferable to convert into it, because it is convertible. If it is a non-convertible function, then a different matter. Then you have to use only this type B kind of technique, because now it is become it is convertible into the type A kind of problem. I'm saying that you may actually prefer this kind of usual method. Okay, now that is left to you. Now we come to next problem. You just take. Motion of a particle along a straight line is described by the equation x is equal to, okay, therefore now there is nothing but independent variable is time, therefore straightforward type A kind of problem, where x is meter, t is 1. What is the retardation of the particle? Velocity becomes 0. Therefore now straight away now x is equal to given, the dx by dt velocity is now differentiated, you get this. And then what is the acceleration they are asking? Retardation, that means negative, you will get it. Therefore then differentiate once more to get acceleration. Therefore then put the condition when velocity equal to 0 means, okay, solve for t here, put it here, you get the answer. Understand? Therefore read the next problem. A particle moves a distance x in time t according to relation x as a function of time. Therefore now straightforward method, because independent variable is time. Now the acceleration of the particle is proportional to. Now here they don't want acceleration as a function of time, they want acceleration as a function of either x or velocity, because options deal with only velocity or distance. Therefore, it's now slightly a little bit more mathematical work is involved in this. Let us see how to do this. Okay, now follow the straightforward method. Because they are given x as a function of time, then differentiate to get v as a function of time, and then differentiate to get a as a function of time. And therefore, then what happens? Now we have to express a as either a function of x or as a function of b. How to do it? By means of eliminating this t plus phi. Okay, t plus phi can be got as this is now. In terms of v, you can actually now do it, as well as in terms of x, you can do it. And therefore, now you can check up the answer, and whichever is convenient, you can do. Now in this particular case, I just now shown you about how to eliminate the t plus phi and then get acceleration as a function of x. Because it is now t plus phi power 2, then 2, and then t plus phi power minus 2 multiplied by 3 by 2 will give you this. Therefore, now t plus phi plus minus 2, why I put it is because I want to get in terms of velocity. Therefore, it is equivalent to 2 into minus v power 3 by 2. Therefore, we can straight away say it as minus or plus, it is proportional to is what they are asking. Therefore, you can straight away tick as option A. Whereas you want to check out about this other options with reference to distance, you can still do it like this, because A is equal to 2 into t plus phi power minus 1 power 3, because this is what it is. This can be written as like this. Therefore, then what happens? T plus phi power minus 1 represents x. So replace it with x, you get then 2x cube. Therefore, 2x cube does not satisfy any of this, either this or this. Therefore, the option A is the only thing which is correct. Now in this particular case, I want you to now understand one more trick. What is the trick is, as long as they are asking proportionality only, okay, they don't want to know the actual expression, actual function. Okay, for example, now if they ask what is the actual function, then you can write this as well as this in terms of the acceleration is a function of velocity like this, or acceleration, if they are asking about the function of displacement, you can write this. Whereas now they are not exactly particular about exact function, whereas they want only proportional to what. Okay, therefore in such kind of cases where they want proportionality only, then you can use a simpler technique which is like this. Okay, let me just now explain what is the technique involved in this. Now in all these cases, as I said, wherever they are asking about proportionality, okay, then you start writing like this. Okay, now always now start with this let. displacement be proportional to t power n. Okay, n unknown. Then what happens? You just differentiate once with reference to t, you get velocity proportional to t power n minus 1. And then differentiate once more, you get acceleration proportional to t power n minus 2. Okay, now look at the particular question here. Now they are given that the displacement is a function of t plus 5 power minus 1. Now t plus 5 or t plus any constant, it actually means now proportional to t power minus 1 only. Therefore now in this case n is proportional, n is equal to minus 1 only. N is equal to minus 1. Therefore then what they are asking, acceleration. Therefore in which case then velocity is proportional to t power minus 2, proportional to t power minus 3. Therefore now you can convert now acceleration to t power minus 3 as this is equal to t power minus 2, that is velocity times 3 by 2. Therefore the acceleration proportional to velocity power 3 by 2 is one solution. Then this also can be converted as in terms of displacement. Now acceleration proportional to t power minus 3, which is equal to t power minus 1 because displacement times 3. Therefore x ka cube. Therefore proportionality only. Therefore it is acceleration is found to be either proportional to distance cube, which is not in the options, where a velocity power 3 by 2, which is in the option. Okay, no? Therefore now this is a method. As I said, this is now a trick. Now you want to practice something like this, then I can give you some more kind of problem. Okay. Now this can be applied, as I said, now except when, okay, you should be careful about this, except when n should, that means n should not be equal to 0. Because n equal to 0 means then is a constant function. Correct? No? Because t power 0. Let us say, for example, now n, that means none of this particular displacement should not be proportional to t power 0, or velocity should not be proportional to t power 0. Acceleration can be proportional to t power 0 because that can be constant. Whereas if it is not t power 0, then acceleration is not proportional to t power minus 1. Okay, remember, now in this case what we are doing is we are reducing n to n minus 1 to n minus 2 in this particular manner. Now if now velocity proportional to t power 0, then acceleration by means of our method will come to t power minus 1, which is not correct because velocity proportional to t power 0 means velocity is constant. Therefore then where is the question of acceleration? Acceleration is going to be 0 only. Therefore you have to now be sure that none of these powers of time, that is functions of time, is actually representing a constant function. In which case you cannot use this particular shortcut method, what I am saying. All other cases, whenever you find that the t power 0 does not occur in your problem, then you can happily use this particular shortcut method, which I will now give you another practice question. Okay. A popular question which was asked in both NEET as well as JEE Main some time back is like this. A particle is starting from rest and then traveling along a straight line under constant power. Question is constant power. Then what is the displacement proportional to time power how much? Time power how much is a question which as I said has come already as a PYQ in both NEET as well as JEE Main, and is a very popular question which is asked in several books as well as the tests. Now how to solve it? By means of our shortcut is like this, because now they are asking only the proportionality question. not the exact expression for displacement. Therefore, we can apply our shortcut trick. What is a shortcut trick? Whatever be the type of question, then we'll start with this, that S is proportional to t power unknown n, and therefore velocity proportional to t power 1, the n minus 1, and therefore acceleration because power becomes 1 less by 1, like this. Then what is meant by power? Power we know is force into velocity. What is force? Mass into acceleration into velocity, which means if it is constant, then we can say that acceleration to velocity equal to constant. So then we'll just now fill up this particular data from whatever we assume. The acceleration proportional to t power n minus 2, velocity proportional to t power n minus 1, this must be equal to constant means t power 0. That is, it doesn't depend upon t. Therefore, which means actually what? Now, this actually means 2n minus 3 is equal to t power 0, which means 2n minus 3 equal to 0, n equal to 3 by 2 is the answer, which means now displacement is proportional to time power 3 by 2 is the final answer. So then see this. Now, as I said, only if you get n equal to either 0 or 1, only if you get n equal to 0 or 1, then you may abandon this particular method and then go for the proper calculus, integration, differentiation kinds of things. Okay? Therefore, or rather integration or differentiation, whichever is coming. Therefore, you have to use that only in the case when n becomes equal to 0 or 1. If it, as I said, now if it is 0, which means now displacement is constant over time, means it is at rest. Therefore, whereas the question of velocity becomes time power less by 1, etc., is not holding good. That is, time power minus 1 does not hold good. That's the reason why I said, even if now displacement is time power 1, which is proportional to time, means what a velocity is constant. Therefore, then where the question of acceleration becomes time power 1 power less. Therefore, that doesn't apply. That's the only reason why I said. Now in all other cases, now you can actually do it, provided, as I said, that they're asking only proportionality. They're not asking the exact expression or the function. Okay. Now let's just try out one more case like this, or you want to actually now see how this. Supposing you just do the actual calculus, then how does it work out? You want to see it, then you can try it like this, because in the books, in the books or coaching manuals or your teachers will not give this kind of shortcut method about like what I have given. They'll give the exact calculus method, which will be like this. How they will give you is a kind of, it's a pretty long method, but I just want to now show it to you that how long it will be, which means now power is constant, power is P. Okay, it will also be equal to MAV equal to power. Therefore, AB equal to power M. Then what is AV equal to P by M. So then, which means V dV equal to P by M dt. Then integrate, you get V squared by 2. From initial, I said it's now starting from the 0, therefore this is V. This must be equal to P by M into time. That means V squared equal to 2P by M time. V equal to root of 2P by M root time. What is dV? dV equal to ds by dt equal to so much. Therefore, the ds equal to root of 2P by M root t dt. Therefore, then integrate again, you get s equal to how much? Root of 2P by M is constant remain. This is t power 3 by 2 by 3 by 2. Therefore, from here you can say proportionality is like this. Okay, fine. Now there's no need to do as I said. We can do our shortcut. Okay, as I said, now I'll give you one more trial practice question. Okay, we can take any question whatever comes to our mind. Like for example, now I'm saying a particle is moving as per. Now we will now say that the velocity, or rather I'll say now time is proportional to acceleration power minus 7, or let us say minus 7 by 2. Okay, time proportional to acceleration power minus 7 by 2. Then what is velocity proportional to s power how much? Okay, so then this is what it is. Now let's now do like this. Therefore, we'll again start with s. Let s proportional to t power n. Therefore, then velocity is proportional to t power n minus 1. Acceleration proportional to t power n minus 2. Now, and therefore, now this actually means the acceleration power 1 by n minus 2 proportional to t. Now it is given that therefore 1 by n minus 2 equal to minus 7 by 2. 1 minus n by 2 equal to minus 7 by 2. And therefore, what is n? N minus 2 equal to minus 2 by 7, or n equal to 2 minus 2 by 7 is 12 by 7. N equal to 12 by 7, therefore velocity equal to, that means s is proportional to 12 by s proportional to t power 12 by 7, velocity proportional to t power minus 1 is 5 by 7, right? And therefore, what is the question of velocity, which is equal to, this is equal to t power 12 by 7 whole power 5 by 12. That means velocity proportional to s power 5 by 12. This is the answer. Okay, understood? Yeah. So now this is just one example what I wanted to give you that. Right. Okay. Now, therefore, as I just repeat, that whenever you have a question not asking for the exact expression, but then asking only proportionality question on this, you can use this particular technique, which will give you the answer within a short time. Now, I have given you enough practice questions for you to try out. Now you can go through this. Now all these questions have been asked either in the past NEET or in JEE Main. Now you want to actually now see how it looks like. Okay, just briefly we will just go through them and then try to say whether it is a complicated or a simple one. As I said, no, for the NEET level, it's not going to be a difficult level. Therefore, I'll tell you also when it is NEET people can actually skip this particular question or not. Okay. So now let's now have a look at the kind of questions briefly, and then analyze what should be the method, and then go to the next question. Okay, read the first question. Question number 29. The position x of a particle with respect to time t along x-axis given by, that is yes as a function of time is given, and then what will be the position of the particle, that is what is the value of x when it achieves maximum speed. Maximum speed means dv by dt we must equate it to 0. Otherwise, acceleration we must equate it to 0. That will give you v max, correct? No? From your knowledge about the calculus, you know that any function will be maximum when its derivative with respect to any variable is equal to 0. Therefore, now here what happens is it's like this now. Okay, just go through this solution briefly. Velocity function. Now, displacement function is given. Differential velocity function it says now v should be max, means difference dv by dt should be equal to 0. Differentiate it, find out the time value, put it back because they want what is the x position. Put it back. Okay, now go to the next question, number 30. A particle moving along the x-axis has acceleration f at time t given by f equal to f naught. That is, instead of acceleration a is what the symbol we use, they have used f. Okay, f is equal to f naught into 1 minus t by t, where f naught and t are constant. The particle at t equal to 0 has 0 velocity. Okay, that's a initial condition for helping you with the integration limits. Then in the time interval between t and the instant when f equal to 0, the particle velocity is. Okay, now it's like this. Now they are given acceleration. It's a acceleration function they are given. If you integrate it, you get delta in velocity. Integrate it, you get delta in velocity. And then what happens is, then you proceed. Now delta velocity, and then what is this thing which they want? What is the time interval? What is the time interval between t equal to 0, lower limit, to the instant when f equal to 0? When it will be equal to 0? When time is equal to capital T. Therefore, we are taking the limit as from 0 to capital T a dt. When you just do this, you get f naught t by 2. Understand? Okay, simple. Now, okay, read the next question. A particle moves along the straight line OX. At a time when t in seconds, the distance in meters is given by this expression, displacement. How long would the particle travel before coming to rest? That is, therefore, then what is now? It now becomes very simple. It now becomes very simple. We have to use this expression, then differentiate to get velocity. When the velocity becomes 0, we have to put, okay, try to see this. Now they put differentiated, you get velocity. Put velocity 0 because you should come to rest is the condition. Then you get time t equal to 2. I put it back to get to know what is, to be able to answer this. How long? Actually, it's a kind of a wrong this thing. What is the distance would the particle travel before coming to rest should be. How long means how time. Therefore, they don't want the time, they want the answer in terms of meters. That means it should be actually worded as how much distance would the particle travel before coming to rest. Any case. So then the pretty simple. Now go to the next one. Displacement of a particle varies with time as. The displacement as a function of time again. 1 second. So this is displacement as a function of time, where a, b, alpha, beta are positive constant. Then the velocity of a particle will be simple in the sense they want velocity expression is like this. Differentiate it, you get it like this. In order to know about whether velocity increases or decreases with time, we have to differentiate once more to get this. Therefore, then what happens? This becomes plus always, this becomes plus always. The velocity increases with time. Therefore, this is what is the answer, D. Understood? Okay, fine. Now, let's go to the next question. The displacement of a particle is represented by the following equation. Therefore, they are given S as a function of time. Then, the acceleration of particle. Pretty simple. We differentiate twice, you get acceleration as a function of time. Put the time value t equal to 1, you get the answer. Next question. The displacement of a particle varies with time as so and so. Acceleration of the particle will be 0 at time equal to. Again, the same kind of this thing. Differentiate twice, you get acceleration expression. Put acceleration equal to 0 and find out what is the time at which this is going to be 0. Fine. Okay. Now, next question. particle moves along straight line, displacement with s as a function of time is given. Therefore, velocity when the acceleration is 0, you have to differentiate it twice, get the acceleration expression as a function of time, put the acceleration equal to 0, solve for t, and then put it back into velocity expression and get the answer. Okay, simple again. Fine. Then, then that's what it is. Okay, so then we could see that all questions are pretty simple. Okay, pretty simple. Now we go to JEE main type of question which has come. Therefore, NEET people need not attempt the JEE type of questions. On this, we will just see this. Yeah, this is only for JEE people, whereas NEET people can actually need not do this. They can skip this portion because this is going to be a higher level. For you, it is not required. A particle of mass is given, i- is moving along a straight line with retardation 2x, where x is the displacement. Its loss of kinetic energy for the above displacement is how much? Loss of KE. Now just look at this. Now, loss of K, that is delta in KE is given by work done. Work done is, we have to take it as integration because acceleration is depending upon, is a function of displacement. Therefore we have to do integration, force MA into dx, and from what to what? From 0 to x. 0 to x. Therefore, integrated, you get a minus mx squared, and therefore this can be written in the form like this, and therefore now compare it with the form in which they want it. So the x, then the index is n equal to 2. Okay, then read the next question. A particle is moving along a straight line. Variation of x as a function of time. Therefore, wherever you have this x as a function of time or v as a function of time, it's a pretty straightforward because you can go about v is equal to ds by dt and a equal to dv by dt. Straightforward, direct methods. Okay, therefore now this question is very simple. They are given x as a function of time. They are asking what is the velocity when the accident becomes 0. I think we have just done it some time back. Differentiate, you get velocity. Differentiate, you get acceleration. Put acceleration equal to 0. Find out the time and then put it back into velocity. Understand? They will give the answer. Then go to the next question. The relation between time and x. Now it is now different because they are given this as the time is a dependent function, and then the displacement is a independent function instead of the other way. Therefore, it is a little bit complicated, but then we will just see how it is. Okay. Where now they are given time as a function of displacement x. Then 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 the relation between acceleration and velocity is okay. Fine. Now look at it carefully. Now t is a function of x. Therefore, now you find out, calculate now dt by dx is going to be, that is, you can differentiate t with respect to x. Then what happens? Then you get 1 by v. Therefore, put it into 1 by v. And also next they want the relation between acceleration and velocity. Therefore, now define acceleration because now you got now v. Okay, just see the working. Now, t is equal to alpha x square plus beta x is the expression which is given. Therefore, now differentiated 1 by v, you get 2 alpha x plus beta. Then differentiate once more, you get x, which means minus 1 by v squared dv by dx equal to 2 alpha x. Okay, differentiate it once more with respect to x because you want to use this particular acceleration equal to b dv by dx. Therefore, from here you can actually take over dv by dx and then put it back into this. Therefore, you get A equal to V dV by dx is equal to minus 2 alpha into V cube. Understood? Okay, because you just do this, this is what you have got, then multiply with V in order to get this acceleration equal to V dV by dx. You get this, and then take the correct answer. Understood? Okay, now just say the next one. Particle moves along a straight line, so the displacement is given by displacement square equal to 1 plus t squared. Okay, acceleration at any time is, now differentiate with respect to x, with respect to t, you get this, which means xv equal to t. Differentiate again with respect to t, you get this. Then you put back from here, now t square, substitute t squared, you get in terms of x. Understood? Go through it once more, you will understand it much better. Okay, let me just repeat this. You are given x squared equal to 1 plus t squared is straightforward. Either you could use now x equal to root of 1 plus t squared, and then dx by dt, and then acceleration at any time t, right? Now, or straight away go about differentiate with respect to time. You get 2x dx by dt equal to 2 dt. dx by dt is equal to v, therefore this actually means xv equal to t. Then differentiate once more with respect to t, because you want to get down to acceleration. Therefore, now this becomes, what happens is now uv method. Therefore, first difference dx by dt into v is v squared, plus x is constant, and then dv by dt will give you a equal to 1. Therefore, from here, now you get, now instead of now v squared, you just put it back as t by x squared from this. Okay, so that you want to get ultimately in terms of x. Therefore, now you just substitute back instead of v squared, you want to eliminate it. Put it back from the earlier equation, v squared equal to t squared by x squared plus xe. Now you got a in terms of x and t. Now you have to eliminate the t also by using the first equation given. And therefore from here you just eliminate the t, and therefore you get everything in terms of x. Therefore is what you get finally. Understood? Okay. Now question number 69. If t equal to given as root x plus 4, then dx by dt at t equal to 4 is how much? Okay, now answer is 0. How? Now dx by dt, therefore this becomes, you can write like this, t equal to root x by 4 is given. You can convert it into x equal to t minus 4 power whole squared. The dx by dt is equal to 2 into t minus 4, and then at t equal to 4, this is going to be 0. dx by dt is going to be 0 at t equal to 4. That's the question which is asked. Okay, now let's take the next question. The instantaneous velocity of a particle moving along a straight line is given as velocity is alpha t plus beta t squared. The expression which is given where alpha beta is constant. What is the distance traveled by the particle between 1 and 2 seconds? Okay, now v is given as a function of t. Therefore, no straightforward method. Function of time. So we integrate it to get x displacement as a function of time, and then fill up between the time limits t equal to 1 to 2, you get the distance traveled. Straightforward. Okay, next question. A relation between time t and distance x for a moving body is given by t equal to mx squared plus nx, where m and n are constant. The retardation of the retardation acceleration will become negative value. Okay. Now see this, how the working is given. Now because it is now t as a function of this thing, you take now the dt by dx, which stands for 1 by v, equal to 2mx plus n. This is the first equation. Then differentiate once more, because we want dv by dx for your acceleration. Therefore we have to do this dv by dx. of this particular expression, which equal minus 1 by b square dv by dx is, now right hand side becomes 2m. Therefore, from here you take dv by dx like this, and then substitute back into acceleration equal to v into dv by dx. I think we just now did this similar kind of problem earlier just now. Okay, therefore you get this 2mv cube. Then, yeah, this also we did something very similar to this question, whereas now the function is different. Now they are given the force. A particle of mass m originally at rest is subjected to a force whose direction is constant but magnitude varies with time as per this. That is force equation they are given, which is in terms of time, which means they are given acceleration equation, because divided by mass you get acceleration. Therefore, then what is, then they are asking what is the velocity of the particle after a time 2t, right? So now what you do is acceleration given as a function of time, then v is wanted. Therefore, integrate it. What is acceleration? dv by dt in terms of time it is given. Integrate it, you get velocity, and then we have to apply between time limit 0 to 2t. Okay, straightforward question. You'll get the answer straight away. Okay, body at rest. Try to do it yourself also once or twice so that you get used to the practice. Next question. Next question is what you have already tried out the trick. Remember, power. Okay. That's all. Thank you.